Hey friends, today we're going to talk about statistics and epidemiology that are hopefully relevant for USMLE Step 1, 2, and 3. So let's get started. This was actually a presentation that I gave during a live session to a bunch of audience. So some slides might not be very relevant, but then I'll try and skip through them. Let's go. So this is a 4-part series, and each part has multiple sessions. This is part 1, session 1. This is basically the question that I try and help you solve by the end of this presentation, but then this is not the only question that you'd be able to solve. This is just to show you how powerful well-learned concepts can be, and then how applicable these whole presentations can be. So let's start by talking about prevalence and incidence and things of that sort. The best way to think about them is to think mathematically, and we'll get into the details of that. But then for now, I'd want you to commit to one of these answers, or 2 or 3 of these answers, how many you deem is correct. So the question is, what happens if survival is improved? So once you have already chosen the answer, look at this. The right answer was the prevalence should increase and incidence should remain the same. So how do you think about this question? You think about this question in terms of P is equal to I into D, that is prevalence is equal to incidence into duration. So if incidence increases, prevalence increases. If duration increases, prevalence again increases. Prevalence increased due to increased disease duration, and constant disease incidence is the case of increasing survival. And then the question would never ask you directly what happens when the survival increases. They would sort of like make you into thinking, like they would give you things that might clue you into thinking that the survival is increased. For example, geriatric care has increased, or a new drug that improves mortality has been found, or something like that. So another example is if diagnostic accuracy is improved. Again, think mathematically, think P is equal to ID, prevalence, incidence, and duration. So if diagnostic accuracy is improved, then diagnosis will increase, of course. So that means that more disease will be diagnosed, meaning more incidence. If incidence is increased, prevalence has to increase. I know this can sound very intuitive, and then you might think that even P is equal to ID is unnecessary, but then during the exam environment, the stress can sometimes get to you, and then it might be very difficult to like intuitively think about things. That's when these sort of like mathematical heuristics can come very handy. So if primary prevention is what the question is asking, for example, a vaccine or things of that sort, then diagnosis will decrease, because if you give vaccine, chances are they will not get ill very frequently. So incidence will decrease. If incidence will decrease, P is equal to ID, prevalence will decrease, right? What about the duration? For example, flu or disease of sort, duration of illness, or sometimes it can be, for example, what can we talk about? Cancer, which is a long duration of illness. So prevalence of cancer would be high, flu would be low, although incidence of flu is high because the duration is low. So even the incidence increases, duration decreases so much that the overall product, I into D, is low. Now let's talk about incidence rate. Incidence rate is new cases by population at risk. New cases, I put it into modulus, and I'll explain what that means in the next slide. But then I want you to remember new cases and population at risk. So new cases, the modulus is the start and the end of the study. So think about it in terms of you being a researcher, and the denominator, population at risk, that is the thing that you would know at the start of the study. So before you start the study, you know who are at risk, but only after you conduct your study and complete your study, you would know how many people got ill during the period of study. That is the numerator, number of people that got ill during the period of study. How many cases did you find, no matter what happened to them during their study? So duration is an important concept here. The other way of looking at it is that the population at risk is a point estimate, meaning who are at risk at this point in time, and new cases is a period estimate, meaning how many people did you find during this period. So The other way of looking at this whole thing, sort of like overview way of looking at it, is that prevalence is a point estimate. It's a snapshot estimate. You go to a community and ask, do you have this illness? Yes or no question. And the incidence rate is actually a period estimate, like we described. You'd have to like go through sort of the study and then see what happens during the study, how many people get sick. So now let's talk about pre and post-test probability. So I see people being confused with sensitivity, specificity, positive predictive value, and negative predictive value. Well, the formula is very easy, and I'll talk about the definitions as well. But then the point of confusion usually is what is the question asking you? Is it asking you to provide sensitivity or positive predictive value, specificity or negative predictive value? So we'll try and deal with that. I propose the formula for all of this: sensitivity, specificity, positive predictive value, and negative predictive value is truth by population. And I would also want you to be aware that we determine population first and the truth. That's the central dogma of sort of this whole statistic course, if you will, that you'd always determine the denominator first, only then you'll go to numerator. So what is the population here and what is the truth? We'll talk about that. Sensitivity, you define it like in a various standard ways, but then the most intuitive, I think, is that to define it as among 100 diseased patient, how many will your test say are diseased? So sensitivity, a highly sensitive test would be used as a screening tool, because it would say that among 100 diseased people, if you imply the test, then it'll say that 100 of them are disease, and that's 100% sensitivity. Specificity is among 100 healthy people, how many your test will say are healthy. So positive predictive value is among 100 people who already have positive test, how many are likely to actually be diseased. Negative predictive value, among 100 who already have a negative test result, how many of them are actually likely to be healthy. So we'll talk about this in more detail, and it'll make more intuitive sense. But then let me try and hammer down the concept that all of this can be calculated by truth by population. So sensitivity, again, sensitivity is about the diseased population. So truth by population, the population is diseased population. And like you can see here, the population is what this arrow shows: true positive and false negative, because gold standard shows these are the diseased population. No matter what the test says, when we say diseased population, we mean whoever is positive by the gold standard. We do not doubt gold standard. For example, if it's cancer we're talking about and biopsy is positive and they have cancer, so true positive and false negative. So all of these two is the population, because they are the diseased population. And this is a property of a test, meaning it does not change depending on which population you apply the test to. It's a property of the test. It'll always remain the same. Specificity, the population is the healthy population, meaning all the people that the gold standard said are healthy is your population. So you already know how to determine population part of it, the denominator part of these two. And it is also a property of the test, would not depend on the population, and then we'll talk about it more. So positive predictive value, the population is, what's the population? The population is every one that your test says is positive. So positive predictive value is the property of the test in a context, in a population. It will change depending on where you imply the test. For example, there's a population of, say, 100,000 people, and one of them has COVID, and you apply the test that says that no matter what the sensitivity, specificity, positive predictive value, or negative predictive value of the test is, you apply the test, and then the test says that this person that you applied the test to has COVID. Now you know that the prevalence is just like 1 in 100,000. What are the chances that your test is true? That versus you apply the same test on in a different population, and then in that population 50% of the people already have COVID, unfortunate population. So what are the chances that your test is correct at this time? That is sort of the framework for looking at positive predictive value. Now, negative predictive value, the population is whoever your test said are negatives. So it be true negative or false negative. So for all this, now I want to talk about numerator. The numerator for positive, negative predictive value first is truth, right? Truth by population. The population for negative predictive value is everyone that your test said is negative. So false negative and true negative. But the truth is just the true negative. It is where the test aligns with the gold standard. So true negative divided by false negative plus true negative would be your negative predictive value. Same goes for positive predictive value. The population was everyone that your test says is positive. So true positive and false positive. What is true there? The place where gold standard and test align. So true positive divided by the sum of true positive and false positive. For specificity, the population was healthy people. How do you determine healthy people? Whoever the gold standard said were negative. So false positive and true negative. And how do you determine the formula? Truth by population. You know the population. Now the truth is wherever these two align. So true negative is the truth. And for sensitivity, same. The population is everyone that are diseased. So everyone that the gold standard says is positive, true positive and false negative. And the truth is wherever they align, so true positive. So if that makes sense, now we can move on to the question. So the question was, So the question was in a population of certain number of people, and the question does not give that 1% of people have COVID. COVID test are 90% sensitive, 80% specific. A man got positive test result. So what are the chances he has COVID? First, the man already got the test result. So now let's talk about pre and post test probability. Pre-test probability is the probability before you already have the test result. So if the question says that the patient already has the test result in his hand, that means it will either ask you positive predictive value or ask you negative predictive value. The question is not going to ask you sensitivity or specificity. The patient does not have the test in hand, the result is not yet known, then the question is more likely than not going to ask you sensitivity and specificity. So that's the distinction. Pre-test, meaning test has not been implied. Even then, we know certain probabilities. Those are sensitivity and specificity. Post-test, meaning test has already been implied. You already have the result. So now, if they ask you, they are going to ask you about post-test probabilities, so positive predictive value and negative predictive value. That's how you know what they are going to like what are they asking, so that you can calculate using truth by population and then arrive at the conclusion. But then this question is a bit more complicated than that, and then there are steps to solve this question. The steps are first you'll find the population, or just sort of assume that there are 100 people in the population. Second step is to use the given prevalence to find out the number of diseased people in the population. Think about it for a second. If the question says that there are 10 people in a population and then the prevalence is 5, so that means that 5 people are diseased, right? So that means that if you imply the gold standard test in that population, then you'd find 5. So if you apply a gold standard test to a population, what does that mean? What is that population in terms of like 2x2 table? Let's see. The population is true positive and false negative added, right? So when a question gives you prevalence, what they are giving is they are giving true positive and false negative added. That's one thing I want you to be aware of. So in this question, they gave that the prevalence was 1%. So true positive and false negative added is 1%. But then the first step is to assume the population if you don't have the population. Here we don't have the population, we assume it's 100. And the second step is to use the prevalence to sort of like guess this. So now, after we're done with the first step, we go to the second step and we guess what the second step is. Ignore this slide. This was something we had a discussion on during the live session, but then go to this slide. So step 2 is to use the prevalence, which is 1, to sort of guess this side of the table, the left side of the table, true positive and false negative. So that's 1. Now, that is what is shown here. So if that is 1, then we have also been given the sensitivity. Sensitivity we know is about the diseased people. what is the formula? Truth by population. What is true here? True positive divided by population, true positive and false negative. But we already know the population and we already know the sensitivity. That would give us the value of true positive. That would be 0.9. We can plug it in, and then if this is 0.9 true positive, then false negative has to be 0.1 because the total is 1. We know that from prevalence, and we know this is 0.9 by using the formula of sensitivity, and we know the formula because it is very easy. Truth by population, and that is equal to 0.9 because 90% sensitivity is given. So after that, we go and do the same thing with specificity. Specificity is equal to truth by population. Truth here is true negative, population is true negative, and false positive. We know that because for specificity, the population is the healthy population, and healthy population is whoever the gold standard says are negative. So if the right side of the table, this 2 is 1, then, and the population we have assumed is 100, then the left side of the, sorry, if the left side is 1, then the right side has to be 99, 100 minus 1. So if it's 99, and if we imply, if we plug in the numbers, because we have sensitivity is 0.8, so 0.8, and we add this, it's 99, then we'd get true negative from that formula, and then that would be 79.2. So if you're following along, then you'd be able to fill up the whole table. And from here, whatever they ask you to determine, you can just determine that. So that's how you solve that. I hope you understood what that means. And now we're going to add the video here. We also talked about odds ratio and stuff during the live session, but then I'd add all the slides that are after this in the next video in the interest of time. So take care. I hope you enjoyed it, and I try and post the other videos that we do during our live Zoom session. If you want, you can join live Zoom session. I usually post the link in USMLE Nepal Facebook page, and you can also go to usmlenepal.com to find out more. Thank you. Bye-bye. I hope that helps.